What if you could expose the same function through multiple URI patterns, letting clients access your data in whatever way makes sense for their workflow? We'll see how to register a single lookup function with two different resource URIs, so clients can fetch user information either by email or by name. This pattern keeps your implementation clean while offering flexible access points for different use cases. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals data server. Hash define a user lookup function that can be accessed by different identifiers. Def lookup user name. SDR none equals none email. SDR none equals none dict. Look up a user by either name or email. If email. Return find user by email. Hash pseudocode. Elif name. Return find user by name. Name hash pseudocode. Else. Return error. No lookup parameters provided. Hash manually apply multiple decorators to the same function. MCP resource. Users //email/email. Lookup user. MCP resource. Users //name/name. Lookup user. This demonstrates the multi-root single handler pattern, where one function serves multiple parameterized endpoints through declarative URI templates. The key concept is URI-based dispatching. Instead of creating separate functions for similar operations, you define a single implementation and expose it through multiple URI patterns. What makes this distinctive is the separation between routing configuration and business logic, achieved by manually applying decorators to the same function. The pattern works by leveraging FastMCP's resource template system, which treats URI paths as first-class parameters. Each decorator application creates a distinct endpoint that maps path segments to function arguments, while the core logic remains unaware of how it was invoked. This approach follows the principle of late binding. The function doesn't know which URI was used to call it, only that it received the required parameters. The framework handles the routing complexity, allowing your code to focus purely on data transformation. This matters because it eliminates endpoint proliferation for conceptually identical operations. Instead of maintaining separate users by email and users by name functions with duplicated validation logic, you write one robust handler and expose it through multiple URIs. The trade-off is slightly more complex registration code, but the benefit is dry routing. Changes to the lookup logic automatically apply to all endpoints. This pattern shines in APIs where the same data can be accessed via different natural keys, like emails, IDs, or slugs. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable tools. It transforms Python functions into endpoints that AI models can invoke directly, handling serialization and routing automatically. MCP equals FastMCP. Name equals data server. This initializes the FastMCP server instance named data server. This central object handles all tool registration, routing, and AI model communication, the foundation for exposing Python functions as callable tools. Hash define a user lookup function that can be accessed by different identifiers. Def lookup user name. SDR none equals none email. SDR none equals none dict. This defines a flexible lookup function that handles multiple identifier types. The optional parameters with none defaults enable calling with either name or email, while the return type dict standardizes the response format. This pattern eliminates the need for separate lookup functions while maintaining clean parameter validation. Look up a user by either name or email. This docstring defines the function's contract, specifying it handles user lookups via either name or email. It serves as both documentation and schema definition for AI tools, ensuring clear usage expectations. The flexible parameter design enables a single function to handle multiple lookup paths through FastMCP's routing.
If email.
This checks if the email parameter has a truthy value, prioritizing email-based lookup when both parameters are provided. The conditional creates a clear precedence order, ensuring deterministic behavior when multiple identifiers could match.
Return find user by email, hash pseudocode.
This delegates the email lookup to a dedicated function. The pseudocode represents an actual implementation that would query your database or user service, returning the complete user record when given an email address. This separation of concerns keeps the lookup user function clean and focused on routing different identifier types.
Elif name.
This handles the name-based lookup path, executing when the name parameter is provided but no email. It's the second condition in the mutually exclusive parameter check pattern, ensuring only one lookup method runs per request.
Return find user by name hash pseudocode.
This is the name-based lookup fallback in the multi-identifier pattern. When no email is provided, it queries the user by name instead, ensuring the function handles both identifier types through a single endpoint. The pseudocode indicates this would integrate with your actual user database implementation.
Else.
This else branch handles the error case when neither lookup parameter is provided. It ensures the function always returns a consistent error response, preventing silent failures when called with invalid arguments.
Return error. No lookup parameters provided.
This is the error handling fallback. Returns a structured error response when neither name nor email is provided, preventing silent failures in the lookup function. The consistent dictionary format matches successful responses, simplifying client-side error handling.
Hash manually apply multiple decorators to the same function. MCP resource. Users //email/email. Lookup user.
This manually applies FastMCP's resource decorator to expose the same function at multiple endpoints. The pattern eliminates duplicate code by reusing one function for different URL patterns, here mapping both email and name lookups to lookup user. FastMCP's decorator syntax works like this: decorator, func, when you need to apply it after definition.
MCP resource. Users //name/name. Lookup user.
This registers the same lookup user function under a second root, enabling name-based lookups through the URI pattern, users //name/name. The decorator pattern allows one function to handle multiple endpoint schemas, eliminating duplicate code while maintaining distinct access paths. FastMCP dynamically extracts the name parameter from the URI and passes it to the function. Resource URI flexibility. The manual decorator application pattern lets a single function respond to multiple URI templates, creating alternative access paths to the same underlying logic. Clients see distinct endpoints, but the server maintains one implementation, reducing code duplication while expanding interface flexibility. This approach scales elegantly as new access patterns emerge, without requiring function signature changes.
The endpoint that appears everywhere has no address of its own.